Alright, the AR Manual Standard Recommended Practice Specification Tanker Cars M1002 Appendix W Introduction Scope. Appendix W describes the AR requirements for fusion welding on tank head, shell, some tanker car tank components, welding attachment connection attached directly thereto. Other welding should be in accordance with American Welding Society welding specification D15-1, latest for revision. Certified facility fusion welding tank car shall be performed only on facilities certified by the AR for fabrication, alteration, conversion, repairs. See Appendix B. Repairs, alteration, conversion for repairs, alteration, conversion, tanker car tanks, Appendix R. Welding symbol of mandatory references. Welding symbol used to conform to AWS 24. Figure 4 to W21 welding terms used in the specification should be interpreted to conform with the definition provided in the latest edition AWS A30. Standard welding term definition, supplemented definition, chapter 1, specification welding symbols shown with the latest edition AWS 24, standard symbols of welding, brazing, non-destructive equipment examination. 1.5 welding size and welding length. Size and length of the weld shall not be less than specified by the design requirement of detailed drawings except they're permitted in 1461. 2. Requirements for non-destructive examination. General. Tanker car tanks and attachments welded directly to the tank must be inspected with non-destructive testing examiner qualified. Appendix B. T. For the method employed in accordance with the following paragraphs for welders, visual acuity requirements to check multi-pass welds. See paragraph 14.1, 14.2. Tank shell joints for manual semi-automatic welding process of welded root pass. Each layer of the multi-pass should be visually checked to make sure they are free from cracks, overlaps, incomplete fusion inclusion prior to disposition of subsequent passes. Welder making welding is responsible for this. We shall be monitored by the welding inspector. Inspection of the joint with the fit up of the root opening, root face, bevel angles, visual inspection, partially completed multi-pass grooves, fillet welds should be done at intervals defined with the facility in-process inspection plan. All completed welded butt joints, grooved welds should be visually inspected in accordance with paragraph 14.10 below. Radiographic examination, ultrasonic and radiograph in accordance with paragraph 18.0 as also is below. 2.3 welded other than tank shell joints attachment welded directly to the tank shell of the root pass. Each layer with a multi-pass weld should be visually inspected to make sure they are free from cracks, overlap, lack, fusion, slag inclusion prior to disposition of subsequent welded pass. Welder making the weld is responsible for this should be monitored by the welding inspector. And inspection of the joint fit up, root opening, root faces, bevel, angle, visual inspection, partially completed multi-pass groove fillet weld should be done in intervals defined in facilities in process inspection plan. A completed weld should be visually inspected in accordance with paragraph 14.10 below. 2. In addition with the requirements of paragraph 221 and 222, pressure car, tanker, and aluminum tank, pressure and non-pressure completed filleted welds listed below shall be examined in accordance with paragraph 10.0 below. For carbon steel tanks, completed welds shall be examined the magnetic particle liquid penetration. For aluminum tanks by liquid penetration where practicable. The completed weld should be examined after post-weld heat treatment, no sooner than 24 hours after welding. Tank anchor pad to tank areas around the ends of the pad, including at least 3 inches of the longitudinal welds. The draft sill pad to the tank around the outdoor of the end pad, including at least 3 inches of the longitudinal weld. Draft sill pad to tank around the inboard end of the pad, including at least 3 inches of the longitudinal welds, except for the pad extended to the full length of the tank. For aluminum tanks, only bolster pad to tank around the upper end of the pad, include at least 3 inches of the circumference of the weld. Ultrasonic testing of the weld may be employed by lieu of magnetic particle liquid penetration inspection. Ultrasonic testing shall be performed in accordance with the requirements of paragraph 10 below. Alright, 3. Test plate requirements. General, when required by DOT or the AR specification, test plate shall be prepared, tested, and evaluated in accordance with the applicable portions of paragraph 3.0, 4.0, and 8.0 below. Item italicized statements, paragraph 3.0 through 8.0 are not applicable to welding procedure qualifications. So below the italicized statement, paragraphs 3 through 8.0 are not applicable to welding procedure qualification. A test shall be prepared during fabrication of each of the welding performance specifications used in fabrication of the tank shell. When more than one welder or welding operator welds on a tank, the test plate shall be made by the welder and welding operator designated fabricator inspector. Test plate shall be prepared for the partial qualification requirements for each welding procedure. See paragraph 12.1.2 below. What impacts are required test plate groove details shall be the same as used for the tank fabrication longitudinal joint test plate. For each tank having a longitudinal weld joint, a test plate shall be prepared for the material for the same specification thickness shell plates of the tank. The test plate material may be taken from any part or one or more plates of the same lot of the material that is used in the fabrication of the tank without reference to the direction of mill rolling, except where the impact tests are required. When impacts are required, test plates should be orientated the same as the shell plates with respect to mill rolling weld directions. Test plate may be detached to the shell plate being welded, reference figure 4 W1A, so that the weld test should be deposited in the test plate continuously with a weld metal deposited in the longitudinal joint. Test plates may be attached to shell plate being welded, reference figure W1A, so that the weld plate should be deposited in the test plate continuously with a weld deposited in the longitudinal joint. As an alternative, detached test plates may be prepared, but weld metal should be deposited using the same welding performance specification used for longitudinal joints. Circumferential joint test plates. When a test plate is welded for the longitudinal joints of the tank, more need for preparing circumferential joints in the same tank provided with the same welding performance specs used for both types of joints. When the welding performance specs circumferential joints are different from one used in longitudinal joints, detached test plates shall be prepared using a welding performance specification used for the circumferential joints. Straightening of the test plates. Test plates shall be supported with the distortion resulting from the welding shall not throw the finished test plate out of line by an angle over 5 degrees. When the welding has distorted the test plate, it shall be straightened before being stress relieved or heat treated. Stress relieving or heat treatment are not specified. Aluminum and stainless steel, for example, test plates out of line by an angle over 5 degrees cannot be mechanically flattened. They must be scrapped and tests repeated. Heat treatment and test plates. The test plate should be subject to the same post-weld heat treatment procedure required in paragraph 16 below, but the related tank at no time should the test plate be heated to a temperature higher than that used for post-weld heat treating in related tank. When procedures test plate impact test specimens required in .AR special commodity requirement, the test plate should be post-weld heat treated with its related tank. Radiograph and test plates weld should be radiographed full length using technique acceptance standards paragraph 10.2 below. If the results do not comply with the acceptance standards, a new test plate should be prepared. 3.7 test specimens required. For tanks built with the materials listed in table 10, M10.1, M10.2, M10.3, M10.4, M10.5, M10.6, and M10.7, the test plate dimensions should be sufficient to provide one reduced section tension specimen conforming to figure 4.2 sketch A plus 2 guided bend specimens, either 2 side bends or 1 face bend or 1 root bend or 1 longitudinal face bend, 1 longitudinal root bend. For tanks built with materials listed in tables 10.1, 10.5, 10.7 that include sufficient material to provide 3 impact specimens for each weld metal heat affected zone when required. 4. Types and purposes for the test. Tension bed macro etching hardness fillet test. These type of tests are used to evaluate welding procedure, welding performance, production welding. Tension test, direct tension tests are used in welding procedure, qualification procedure, welding tests. Joint tension specimens are used to measure strength of butt or groove weld joints. And all welded metal tension specimens are used to measure strength and ductility of the welded metal. Guided bend tests. Guided bend tests are used in welding procedure, qualification, production, weld tests. Guided bend tests are used to measure soundness, ductility, groove of the welded joints. Macro etch tests. Micro etch tests used in welding procedure, welding performance, qualification, production, welding tests. Macro etch tests are used for soundness, weld size measurement, partial penetration, groove welds. Hardness tests are used for required qualification, carbon steel, pressure tanking, welding procedures. In production welding qualification tests, see paragraph 8.3. Hardness tests are used to evaluate welding procedure, production welding, and to control maximum hardness requirements for the repair welds on the AHF tank car tanks. See paragraph R412. Fillet weld test. Fillet weld tests are sometimes used with welding procedure, welding performance, qualification test, check size, contour, penetration, fillet welds, degree of soundness of the fillet weld joints. Impact tests. Impact tests are used to evaluate welding procedure, production weld with the tank surface involved with the transportation of low temperature product. Sharpie impact tests are used to measure notch toughness, low temperature weld metal, weld heat affected zone, butt grooves, weld joints. Radiographic test. Radiographic examination length of the weld is used to evaluate the ability of the welding operator to make an acceptable groove weld a joint. Under certain conditions, radiographic examination may be used in an alternative mechanical test for welding performance qualification. Radiographic examination is recommended for welding procedure production weld test plates to measure acceptance preparation of test specimens. Corrosion tests are used to determine that the weld heat affected zone plate specimen from the test plate made for the materials listed in table M10.3 are not susceptible to intergranular attack associated precipitated chromium carbides may meet the acceptable corrosion rates listed in paragraph M, paragraph 332. 5. Tension specimen and test. Joint tension specimen. Flat reduced section test specimen conforming to the requirements of figure W2 sketch A. In turn, reduced section tension specimen conforming to the requirements of figure W2 sketch B may be used to test welding procedure production welded impact test plates. In turn, reduced section tension specimens are used. One complete test should be made for each of the required tension tests as given below. For thickness 2 and include 1/4 inch of single specimen shall be used. For thickness over 1 1/4 inch multi-specimen shall be cut through a full thickness of the weld. Their centers parallel to the material surface not over 1 inch apart. The centers of the specimen adjacent to the material surface should not exceed 5/8 of an inch from the surface. Joint tension test. Tension test specimen should be ruptured under tensile load. Tensile strength should be computed by dividing the maximum load of a failure least cross-sectional area of the specimen measured before load is applied. The tensile stress of the specimen should not be less than specified tensile strength of the base materials given in table M10. Specified tensile strength of the weaker of the two in the base material of the different minimum tensile strengths given in the M10 are used. 5.2.3. If the joint specimen breaks on the base material outside weld, the test should be accepted as meeting the requirements provided, but strength is not more than 5% below the specified tensile strength of the base material specified in the table M10. 5.3. All welded metal tension test. For all welded metal specimens, the all weld turner reduced section test specimen is acceptable fit end of the fracture specimen, topograpically measured distance between gauge marks the nearest 100th of an inch. Elongation increase the length of the gauge length. Expresses percentage original gauge length. Elongation should not be less than the value specified in the base material table M10. If any part of the fracture takes place outside of the middle half of the gauge left or in punch gauge mark, the elongation value you obtain may not represent the material of the elongations of the meets of the minimum requirements. No further testing is required, but the elongation is less than the minimum requirement. Discarded test, make a retest. And so far, 5.3 has been completely all weld metal tension test has been strike. The tensile strength shall not be less than special tension base material given in table M10. Tensile tension strength weaker of the two if the base material of the different minimum tensile strengths given in table M10 are used. 6. Bend and specimen test. Guided bend test specimens. Guided bend test specimen formal requirements figure W3 sketch B and W4. Be used qualification testing, welding procedure, welding performance for production, weld impact test. Rectangular specimens cut from the test plates for 5 types: side bend, face bend, root bend, longitudinal face bend, longitudinal root bend. The cut surface shall be designated the sides of the specimen. The other 2 surfaces should be called face and root, having the greater width of the weld metal. Guided bend test. Guide bend specimen shall be bent into test jigs substantially according to the figure W5. Inconvenient means may be used to move a plunger member with relation to the die member. The specimen shall be placed on the die member of the fixture of the weld mid-span. Face bend shall be placed on the face of the weld directly toward the gap. Root bend and fillet weld sound specimens shall be placed on the root of the weld directed toward the gap. Side bend specimen shall be placed on the side, showing the greater discontinuity, if any, directed toward the gap. 6.2.3. Specimen of the time bending shall be between the temperature of 50 degrees Fahrenheit and 140 degrees Fahrenheit. Applying the bend test smoothly without shock, bending the specimen into the die at the duration no faster than 15 seconds, no slower than 120 seconds. By applying a load on the plunger at 1/8 of an inch. Diameter wire cannot be inserted between specimen at any point of the plunger. 6.2.4. Convex surface bended test specimen. Visually examine the surface discontinuity for acceptance. Surface contains no discontinuity exceeding following dimensions: 1/8 of an inch measured in any direction of surface. 3/8 of an inch surface. The greatest dimension of all discontinuities exceeding 1/32 of an inch, but less than or equal to 1/8 of an inch. 1/4 of an inch maximum corner crack, except for the corner cracks result of visible slag inclusion and fusion type discontinues, then 1/8 of an inch maximum shall apply. Specimen in the corner cracks exceeding 1/4 inch or 6, with no evidence of slag inclusion or other fusion type discontinues may be disregarded and replacement test specimen from the original weld and it should be tested. Fillet weld specimen test. Fillet weld T-joint specimen. T-joint specimens when required, shall conform with the requirements of Figure W6. The fillet welds shall be made with the qualification testing weld. The performance shall be cut into the provided T-section. T-joint section lateral loading provided cross-section over the weld meant to be smooth. Macro etched with suitable etchant to give clear definition and structure of the welded metal in a heat affected zone. See Figure W6 Sketch B. Fillet weld joints. Typical joint specimen prepared in accordance with Figure W6 Sketch A shall contain no visible cracks. Vertical member of the performance qualification T joint shall be loaded laterally. The load steadily increases until the specimen factory bends down and flat upon itself. To pass, the specimen shall not fracture, or if it fractures, the fractured surfaces shall show with no evidence of cracks, incomplete root fusion. Some of the lengths of the open discontinued visible fractured surfaces shall not exceed 2 inches for furious metals and 3/4 of an inch for non-furious metals. Performance qualification T-joint weld shall have no concavity or convexity greater than 1/16 of an inch. It shall have no more than 1/16 of the difference in lengths of the legs of the fillet weld. The procedure qualification T-joint weld shall have no more than 1/8 of an inch difference in length of the legs of the fillet weld. Visual examination, micro etch, draw section of the weld metal, heat affected zone. Performance procedure qualification T-joint weld shall be freedom from cracks and complete fusion at the joint root, but not necessarily beyond the root. 8. Impact and corrosion hardness tests. Impact and specimen tests. Tests and impact tests are required only when specified with the tank specification material number required. Test plates used to prepare specimen should be provided for each of the tank and shall be one over the heats and provided plates for the tank. When welding is involved, the plate shall be welding using the same joint detailed welding performance specifications and electrodes are required for the tank. Unless otherwise specified, at least one set of 3 specimens shall be taken across the weld with a notch for the heat affected zone. One set of the 3 with notch in the weld metal. See Figure 4.9. The 2 plates of the different materials are involved, and an additional set of 3 specimens should be taken so that there is one set with a notch in each heat affected zone. Type, location, orientation of specimen. Unless otherwise specified, the specimen show the type of the 10mm by 10mm Sharpie V notch prepared in accordance with Figure W10, where the thickness of the plate is not insufficient to permit full-size specimen. A large subsize possible should be prepared, maintaining a depth, 10mm depth of the specimen with the location orientation specimen with the notches shall be as shown in Figure W9. Heat affected zone notch shall be located with the areas of maximum grain size as determined by etching of the specimen. Testing procedure. Specimens should be tested in accordance with the ASTM E23 temperature specified by the tank specification. Following precautions are to be observed. Tank specimens as well as handling tongs should be cooled for sufficient length of the time, usually 15 minutes to reach the test temperature. Test temperature should be maintained in a range of plus or minus 3 degrees Fahrenheit. Test specimen should be transferred from cooling medium to anvil for the test machine and broken with a time lapse no more than 5 seconds. Test results and test retest unless otherwise specified. The tank specified minimum impact test values, full size, sub-size specimens should be shown in the table of W1. Table 1, minimum impact test values. Minimum value each of the 3 specimens. Average of the 3 specimens. Specimen 10 by 10, 10 by 7, 10 by 5, 10 by 2 by 5. Foot in the foot pounds 15, 12, 5, 10, 5, 10, 8, 7, 3, 5. Alright, if the value of more than one specimen is below the minimum value specified for the average of the specimen, the value of the one specimen below the minimum value specified on one of the 3 specimens, the other 2 being is not less than the minimum value specified for the average of the 3 specimens, retest the 3 additional specimens shall be made with each of these which must be equal to exceed the specified minimum value of the average tree specimen. Such as a retest shall be permitted only where the average value of the three specimen exceeds minimum value specified for the one of the three specimens. If required values are not obtained upon the retest, the value of the initial test are below the minimum required for the retest. The welding procedure, welding metal, as the case may be, shall be rejected. When the erratic results is caused by the defective specimen, there is uncertainty in the test procedure. Retest shall be allowed. Reports. A report impact test results shall include identity of the material specification, grade, heat number, PQR, procedure qualification record, welding electrode type, size, impact test, specimen location, orientation, specimen notches, prospective plate, surface rolling direction, welded metal, welded heat affected zone, impact zone of each specimen. The complete route of all the impact tests shall be retained for not less than 5 years for the tank fabricator or the car owner if the owner so requests. Corrosion specimen and test. Tests are required on tanks fabricated for the materials listed in Table 10.3 when required by the tank specification. A2. Material and number required. Test plates used with the repair specimen should provide for each of the heat material of the fabricate tanks. Each heat of the filler metal then used with the welded tanks. Where welding is involved, with the plate shall be welded by using the same welding procedure specification used on the tank. At least 1-3 specimen should be taken with the test plate located as shown in Figure W1. Sketch B. Corrosion testing. Base material that does not require corrosion testing has conducted certified by the material supplier. Specimens should be tested in accordance with the ASTM A262A. Practice A. The result practice A are unsuspectable. Further testing practice B or C is required. Testing criteria. Corrosion testing specimens considered acceptable when exhibit corrosion rates not excessive listed in Appendix M, paragraph 332. Welding corrosion testing specimens need not to be sanitized. 823 report of corrosion testing specimen shall be identified with the plate material specification, grade, heat number, the welding procedure, welding electrode, corrosion rate of each of the specimen tested. 8232, the complete report of all corrosion tests should be retained for not less than 5 years by the tank fabricator or by the car owner if the owner requests. Hardness test of production butt welds are required for pressure tanks fabricated from materials listed in Table 10.1. That was crossed out. Hardness tests are required. Qualification welding procedure of the joint. Pressure tank section fabricated materials listed in Table M10.1. Vickers hardness reading center of the weld. Heat defective zone should be taken in accordance with ASTM E384. Figure W22 for this appendix. Another method of hardness is to be used the equivalent hardness number of the determined ASTM E140. On each tank, at least 3 points inside, 3 points outside the shell. 3 points inside, 3 points outside shall be checked at the center line of the welds. 2 of the inside points, 2 of the outside points. The intersection longitudinal circumferential butt welds grind weld metal to produce flat surface for hardness testing test at these checkpoints. Do not grind weld reinforcement before joining plane surface. Hard welding should not exceed 2.238 diamond period high in hardness or 28 arch rocks well C. After post weld heat treatment, heat affected zone hardness shall not exceed 270 diamond period hardness and 26 rock well after post weld heat treatment. 832 hardness of welds should not exceed Brindle 225 Rockwell C20 after post-weld heat treatment. Hardness tests of the butt welds multi-unit tank car should be performed on exterior welder seams only. One test, hardness of the test, that was crossed out. One test per weld procedure is required on each tank. That was also scored. Macro etch tests used in soundness, weld size measurement, partial penetration grooves, fillet welds, acceptable qualification test specimens when inspected visually shall conform with the following requirements. Partial joint penetration groove welds should be have designated effective weld size. Fillet welds should have fusion of the root of the joint, but not necessarily beyond. Minimum leg size shall meet the specified fillet weld size, should not exceed the specified size or more than 1/8 of an inch. Partial joint penetration groove weld fillet welds shall have the following: no cracks, incomplete confusion, porosity, no undercut exceeding 1/64 of an inch. Complete fusion between adjacent layers of the metal between welded metal and base metal. Welded profiles conform with the intended detail. 9. Procedure and performance qualifications. Rules, paragraph 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 0, 10, 0, 11, 0, and 12, 0 of the appendix apply with the qualification welding procedure welders, operators for all welding processes covered by the specification. This does not preclude the using welding process for the construction, alteration, repairing tanker car tanks. However, this requirement of the design, qualification, inspection, testing related to using such process of the responsibly certified facility electing to use such process shall generate documented evidence conform with the national recognized standards that substantiate their use and the defined essential variables supporting documentation evidence should be submitted to the AAR Tanker Car Committee for approval. 9.2. Responsibility. Each company shall be responsible for the welding procedure specification used for the company by their subcontractor. For the company subcontractor employer should conduct the test required by the appendix qualifying welding performance specification and is used in construction for the weldments built under the specification performed to the welding operators who apply these procedures. When a company changes ownership of the new company shall review the procedure, qualification record, welding procedure specification, performance qualification of welding operators to determine whether they can perform the requirements of this specification. The procedure qualification record should be revised to reflect the name of the new company. The revision shall maintain the record of the original company performing instead of qualification. Properly documented welding procedure specification that does not conform with the provisional specifications may be used without requalification provided for the new company except for the responsibility for that the welding procedure specification is revised to reflect the name of the new company. Welders and welder operators whose qualification records do not conform with the provision of the specification may continue to weld without requalification provided their new company except for the responsibility for the qualification of their qualification records. Reflect for the name of the new company, the revision shall maintain the record of the original company performing in said qualification. Procedure performance qualification is performed to meet the requirements of the earlier edition of the specification while these additions were in effect are valid and may be used to provide requirements of the current edition are still met. Each company shall ensure that the welders are trained, qualified in the areas of welding, symbols of welding procedures, acceptance criteria, other section specifications acceptable to their work. Training shall be documented. Welding performed by the certified company, subcontractor, employer may be used to fabricate, alter, repair, convert tanker car tanks in accordance with the specification, provided all the requirements of the specification are met. Certified company takes responsibility for all the welding. The extent of the subcontractor employer's welding operations should be clearly discernible. 9.3. Records. Each company shall maintain records of welding procedure specification for each of the qualified welding procedure supporting procedure qualification records for the performance qualification welding operators. These records shall be certified by a reasonable official of the company by the means of the signature of the date when certified. The records should be available to those authorized examining them. Companies may centralize the storage of these records. Recommended forms of these records are shown figure W11, W12, and W13. Identification of the welds. Each qualified welder operator should be assigned a unique identifying number letter of the symbol by the company. Assigned identification shall be used to identify the work of that welder and welding operator. Qualification restrictions. Facility should use the AAR qualified welding operators. ASME performance qualification for the plate materials listed in the Appendix M of the paragraph 3 may be accepted at the meeting of the requirement. Radiographing using ASME performance qualification must be in accordance with Appendix W, completed with a test weight. Assemblies must be visually inspected in accordance with the paragraph 14.10 below, with paragraph 14.5 and the paragraph 14.6 also below as applicable. For qualification procedure, welding operators utilized to the company shall be under the full supervision control of the company. Each company shall qualify the welding procedure, welding operator to produce the welding meeting the appendix. A procedure qualification record from one company shall not be used to qualify a welding procedure specification for another company. An exemption of the requirement 952 is allowed for one certified company A contracts another certified company B to perform the welding on the equipment they own. In this instance, the certified company B performing the weld may elect to utilize the certified car owner's Company A's welding performance specification performance of their welding. Both companies shall agree to such exemptions. All of the other requirement specification pertaining to the qualification welding shall be met. Welding with a test specimen that provide the qualified procedure qualification record cannot be subtracted. It's permits the welding with a test specimen to produce a weld procedure qualification record cannot be subtracted. Impermissible, the subcontractor preparation test materials for welding preparation of the test specimens and completed weldments, non-destructive examination, mechanical testing provided with the certified company accept the full responsibility for any such work. Welded orientation and test positions. All welds used for the actual production shall be classified as 1 flat, 2 horizontal, 3 vertical, and 4 overhead in accordance with the definition welding position paragraph 962 through 965 below in weldings in figure W7 and W8. Groove plate test welds, figure 14A. In making the test groove, qualifying a groove weld test plate shall be welded at least one of the following positions. Position 1G, flat. The test plate with a maybe approximately horizontal plane with a weld metal deposit on the upper side. Position 2G, horizontal, shall be placed approximately vertical plane with a groove approximately horizontal. Position 3G, test plate should be moved approximately vertical. Position 4G, overhead, the test plate should be placed approximately horizontal plane, and weld metal should be deposited from the underside. A manufacturer who does production welding and special orientation may make a groove plate test welding procedure qualification with a specific orientation. Such quantity qualifications are valid only with the positions actually tested, except for the following: for other than vertical position test welds, an angular deviation of plus or minus 15% is permitted in an inclination of the weld axis for the rotation of the welded face. Vertical position test welds qualify all vertical positions of lesser inclinations. A groove pipe test weld, forms W14B, making the test qualifying groove weld test pipe shall be welded with the following position. Position 1G, pipe horizontal, rolled. The test should be placed with axis horizontal, groove with approximately vertical. The pipe should be rotated during the welding. The welding is deposited for the upper side. Position 2G, pipe vertical, fixed. The test pipe should be placed with the axle vertical with the welding groove approximately horizontal. The pipe should not be rotated during welding. Position 5G, pipe horizontally fixed test pipe should be placed for the axis horizontal with a groove approximately vertical. The pipe is not rotated during welding. Position 6G, pipe inclined fixed. Test pipe should be inclined at 45 degrees with a horizontal with the pipe is not rotated during welding. A manufacturer who does production welding and special orientation may make groove pipe test weld procedure qualification specific orientation. Such qualifications are valid only if the position actually toward tested, except for the angular deviation plus or minus 15% is permitted by the inclination of the pipe axis. Fillet welds in a plate. In figure 14, W15A, the making test qualifying fillet welds test plate shall be welded with the position outlined below. Position 1F, flat. The test shall be placed with each fillet weld is deposited with the axis approximately horizontal throughout with approximately vertical. Position 2, horizontal. The test plate should be spaced. Each of the fillet weld deposits down on the upper side of the horizontal surface against the vertical surface. Through position 3F, vertical. Test should be placed with each fillet weld deposit in an approximate vertical. Position 4F, test plate should be placed each fillet weld deposit on the underside of the horizontal vertical against the vertical surface. A manufacturer who does production welding and special orientation make up the fillet plate test welds procedure qualification specific orientation. Such qualifications are valid only for the position actually tested, except for the following: for other vertical position test welds, figure W7, the angular deviation plus or minus 15% permitted with the inclination weld against the rotation of the welded face. Vertical position test weld qualify vertical position fillet welds with lesser inclination. Fillet welds in pipe, figure W15B, flat position 1F, test pipe should be placed with the axis at inclined 45-degree horizontal, rotated during welding. Weld metal is deposited from above the pot pointed to this position, axis weld horizontally welded side vertical. Horizontal position 2F2FR. The position 2F, the test pipe should be placed axis vertical so the weld is deposited on the upper side of the horizontal surface against the vertical surface. The axis for the weld should be horizontal and the pipe not rotated during welding. 2. The position FR test pipe should be placed on the axis horizontal axis deposited weld vertical plane. The pipe is rotated during welding. Overhead position 4F, the test pipe should be placed axial vertical so the weld is deposited on the underside of the horizontal surface against the vertical surface. The axis of the weld should be horizontal to the pipe not rotated during the welding. Multiple position F5, the test pipe should be placed on axial horizontal with the axis for the deposit weld in a vertical plane. The test pipe is not rotated during welding. A manufacturer who does the production and special orientation may make fillet pipe test welds for procedure qualification, and the orientation such qualification are valid only with the position tested, except for the angular deviation plus or minus 15% permitted with the inclination of the pipe axis. Performance qualification above position shall permit within range of the orientation specified with the position according to the table W2 as shown in figures W7 and W8. Welders who pass the required groove and fillet weld test listed in paragraph 962, 963, 964, and 965 shall be qualified position with the groove for the positions of the groove weld and fillet weld shown in table 4 W2. So we have qualification test, welding type, plate groove, 1G, 2G, 3G, 4G, 2G, 3G, 4G. Plate fillets, 1F. Plate structural shape box tubing pipe over 24 inches in diameter, and pipe 24 inches under diameter. No grooves, just fillets. Pipe groove 24 inches under diameter. Pipe fillet 24 inches under diameter. Pipe groove 24 inches under diameter. Pipe fillet 24 inches under diameter. Okay, a company that does fabrication, repair, alteration, conversion, particular positions make it tests in that position, but such performance qualification is valid only when the flat position for the position actually tests except for the angular deviation plus or minus 15%. Permitted with the inclination of the weld's axis, the rotation of the weld's face as defined in figure 4.7 and 4.8. Alright, 10.0 non-destructive examination acceptance standards.